Hello and welcome back. These will be the notes for 5.3, writing equations in point slope form. There is a PDF available if you'd like to print it out and follow along. First thing we'll look at is what is point slope form. It's simply another method of writing an equation for a line which uses the slope of the line and a single point on the line. One thing that you might want to notice here is it's not necessarily the y-intercept that we give you. The form is y minus y sub 1 is equal to m, which is our slope, times, in parentheses, x minus x sub 1, where the x and the y are a point given to you. So x and y is a point that's given to you, and m, of course, is slope. Here's why it works. Remember that the equation or the formula for slope is y2 minus y1 over x2 minus x1. Change in y over change in x. Well, now instead of giving you both points, 2 points, we're going to give you 1 point and the slope. So those are the numbers you substitute in there. So if I rewrite this as y minus y1 over x minus x1 and let that equal m, all I'm going to do to eliminate this from the bottom is multiply both sides by x minus x1, x minus x1, or x value from 1.1. The x's will cancel each other out on this side, leaving y minus y1 equals m times x minus x1. And that is our point slope form. So you'll notice that the point slope form of an equation is really nothing more than a modification or a rearranging of the slope formula. Example 1. Write an equation of a line that passes through the point negative 4, 6 and has a slope of negative 1/3. Well, in place of slope, all we got to do, well, I said negative 1/3, it's actually 1/3. In place of m, all we got to do is substitute a 1/3. Let me put an equal sign here in black. And in place of y, this is x, this is y. In place of y, we put a 6. Yeah, that's not what I wanted. 6 with a in blue. There we go. X minus, and in place of the x value, I have a negative 4, but since I have a minus sign out in front, I better go ahead and put that in parentheses. That's going to be a minus negative 4. Now, technically, that is the equation. All I'm going to do now is modify it so I don't have minus and negative, so it looks a little neater. So y minus 6 is equal to 1/3 x. Instead of minus negative 4, I'm going to put plus 4. Now here's one thing you got to be very careful of. We can clearly see that the slope is going to be 1/3. Most people don't make a mistake on that. However, if I ask what is the point that was used to create this equation, the first instinct for students is to say, well, the point was 4, 6, because that's the number they see here and here. But the point wasn't 4, 6. As we saw from up here, it's actually negative 6. So this part of the equation is normally supposed to be a subtraction. The only way you can get a plus sign in there or an addition is if the point coming in for x had to be negative. So I could rewrite that as minus negative 4. So once I have a minus sign right here, then I know that this value here was my original x, so my x there is negative 4. That's the only thing you got to be careful of. So you could have a plus 6 on the other side as well, and that's another common mistake. But we'll practice that in class. Okay, so we've got our equation. How do we graph using it? Normally we go to the y-intercept and graph. Well, I don't have the y-intercept here. I have a different location on the graph. Remember here that the 4 was not a positive 4 to begin with. It was a negative 4. So the point that I need to graph is negative 4, positive 6. So we'll go ahead and graph that point. which is 1, 2, 3, 4 left, 1, 2, 3, 4, 5, 6 up. And I have a slope, an m value, slope of 1/3. So once I know one point on the graph, I can find the next point by applying a slope of rise 1 and then run positive 3. So up 1 and over to the right, 1, 2, 3, 1, 2, 3 gives me a point right here, and I can do it again. Up 1 and over 1, 2, 3 gives me another point right there. Or I can go in the reverse direction, make them both negative, go down 1 and to the left, 1, 2, 3. And the more points I graph or plot, the straighter my line will be, especially when doing this by hand. So you can see our y-intercept is occurring right around in here somewhere, but it's not a very nice y-intercept. But I don't need it. I have the point -4, 6, and I have the slope. The slope always tells you the steepness of the line and tells you how to find the next location or the next point on the graph. Example 3. Write an equation of a line that passes through the points 1, 4, and -2, -3, but we're going to write it in point slope form. Now point slope form requires a single point, and they gave us 2 points, and that's fine. We can use one of those 2 points, or we can use them both. But one thing that they didn't give us was, they didn't give us the slope. Slope is change in y over change in x. That's my m value. So I need to go ahead and calculate, there's an equal sign here. I need to go ahead and calculate slope. So change in y, 4 minus -3, and that would give us 7. And 1 minus -2 would give us 3. So the slope is 7/3. So if I go ahead and write my equation, y minus, leave a little space for my x or my y point, my slope, I'm going to put that in here, slope was 7/3. And then I'm going to show my x minus. And all I got to do now is drop in my y value here and my x value there. And I only need one point. I'm going to choose the first point. So my y value is a 4 and my x value is a 1 from this point here. Now what if I chose the other point instead? Y minus, leave a little space there, I got my 7/3, x minus. Well, my y value on this one over here is a -3, so I got to make sure I put it in parentheses. And my x value is a -2, so I got to make sure I put that in parentheses. And technically that's it, but I'm going to go one step further and rewrite it without the minus negative in there. So y, instead of minus negative, we're going to put +3 is equal to 7/3 x, and then minus -2 is +2. So we've got this equation here, which is correct. And we've got this equation here, which is correct. And the only thing these appear to have in common is the slope of 7/3. And a lot of students will go, well, how can you have two different equations represent the same line? We're going to see that here in a couple examples from now. If I were to rewrite this in slope-intercept form, even though I have different numbers for x and y, the slope and the y-intercept will end up being the same. So the slope-intercept form of these equations, when I transform them, will look exactly the same, mirror images of each other. So these two equations will actually define or write or describe the exact same line on the graph. Example 4. What equation in point slope form gives the balloon's altitude at any time? So looking at the table, they tell us that time is our x value. The one thing they didn't tell us is what time was. Let's call this seconds. And the y value is representing altitude. They didn't tell us what that was. I'm assuming that's in feet. So let's go ahead and call it seconds and feet. To do a point slope example, we need to have a point and we need to have a slope. Well, I have 1, 2, 3, 4 points to choose from, but I don't have a slope. That means I need to solve for the slope. First thing I'm going to do is I'm going to write down my point slope form. And I just need to fill in my y value, my m value, which is slope, and my x value. Let's suppose I choose the first point, 10 and 640. So this is going to be a 640 here, and this is going to be a 10. That's pretty easy, but I still have to calculate my slope. Remember, slope is change in y over change in x. That's my m value. So let's pick points to calculate. I'm going to go ahead and use point 1 and point 2. I could use any of these points. I'm going to use point 1 and point 2. So 640 minus 590. 640 minus the 590 should end up with 50. Yep, 50. That's the change in y over the change in x. 10 minus 30 is negative 20, and this slope is going to be negative. Now this is the balloon's altitude, and it's negative. I think they're going to discuss this on the second example, or next example. Now this is feet over seconds, so I'm going to go ahead and divide it out. This real world problem, it's okay to divide this out. And this comes out to negative 2.5, and this is 2.5 feet per second. But it is negative. So in place of m, I'm going to substitute my negative 2.5. And all I got to do now is write my whole equation. So y minus 640 is going to equal negative 2.5 times x minus 10. And that is my equation in point slope form. The only thing that would be different is if I chose a different point other than the 10 and 640. The negative 2.5 for slope would still be the same, it'd just be the x values would be different. Example 5, what do the slope and y-intercept represent? Well, this tells me the slope. That's pretty easy to define what's happening there. Negative 2.5 feet per second in a balloon. That's pretty easy. So the slope, negative 2.5 feet per second, means the balloon is descending. So the slope is representing a decrease in altitude of 2.5 feet per second. So the slope is representing a decrease. I guess I should put a colon here. The slope is representing a decrease in altitude of 2.5 feet per second. So the balloon is actually descending. Now the y-intercept, well, we don't have the y-intercept. I have a point on the graph and I have the slope. So the only way to solve for the y-intercept is to isolate y and put it in slope-intercept form. First thing I'm going to do is distribute the 2.5. So y minus 640 is going to equal negative 2.5x. And a negative times a negative is going to give me a positive. 2.5 times 10 is going to give me 25. I still don't have y by itself, so I'm going to add the 640 to both sides. So y equals negative 2.5x plus 665. Now this looks like mx plus b format, where m is the slope, which we already had. We already knew that. And then the b value is our y-intercept. So our y-intercept is 665 feet. So at 0 seconds, x is, remember, time. At 0 seconds, the height of the balloon is 665 feet. So the y-intercept is the starting altitude before the balloon began its descent. Remember, negative 2.5 feet per second means the balloon is going down. It's getting closer to Earth. By the way, if we look at this equation right here, This is our slope-intercept form of the equation. If we'd chosen on the previous slide any of these other 3 points, remember we started with the one on top, but if we chose any of those other 3 points, this equation here would be slightly different in appearance. However, if I had isolated y on all of those, they would all look like this, where the y-intercept would come out to a positive 665. And if you don't believe me, go ahead and try each of those examples, putting a 30 and a 590 in there in the next one and the next one, and see that it actually does come out to the same slope-intercept form.